T-minus 5, 4, 3, 2, 1.
Hello, everyone, and welcome to A Bridge to the Future. We're going to be talking today about a topic that I know is interesting to almost anyone who's interested in space exploration, and that's Mars. And I'm really honored to have Bob Zubrin with me here today. Bob wrote a brilliant book called The Case for Mars. It has had several editions. He's also founder and president of the Mars Society, and he's founder and president of Pioneer Astronautics, which is an aerospace R&D company. And Bob, welcome to A Bridge to the Future. Great to have you.
Thanks for inviting me.
Yeah. Well, it's clear from your titles you're interested in Mars. And I always like to start these interviews asking, how did you get interested in this topic? And what was it that drew you to it? How old were you? And was this a childhood fascination, late blooming? Let us know how you got into Mars.
Well, the first is how I got into space. And that was Sputnik. Okay, I was 5 when Sputnik flew. And I was an early reader. I was already reading science fiction. And while the adults may have been in a frenzy about Sputnik, I was delighted because it meant all these stories about the spacefaring future were going to be true. And I wanted to be part of it. And my parents encouraged my interest. My father got me a telescope. I did drawings of the moon through the eyepiece. I got into model rocketry. I started reading all the books about space that I could get my hands on. And it rapidly became clear to me, certainly by the time I was 9 or 10, that Mars was the most interesting planet. It was the planet that was most Earth-like. Now, of course, at that time, people had an exaggerated view of the hospitality of Mars to life. The canals had not quite gone away, and even when they had, people kind of said the changing colors could be lichens and so forth. But even so, it was clear to me that life was the most scientifically interesting because it could have life on it, and it was the most promising for human settlement. So here we go. It's the 60s. And we're going to the moon by 1970, Mars by 1980, Saturn by 1990, Alpha Centauri by the year 2000. This is the program. I'm all in. Okay. Now, of course, as you know, the only part of that program that was realized, in fact, was the moon by 1970. In fact, we did it before then, 69. And the Nixon administration aborted the push. NASA had plans to land humans on Mars by 81, but that was not allowed to happen. And I was somewhat discouraged by that. By then, I was in college in the early 70s. And, you know, I'm the first generation in my family to go to college. So for someone like that, the notion of you're going to college so you can get a good job afterwards, you know, like that, okay? And so the idea of grad school didn't even occur to me. Okay, wasn't in the cards. And gee, get real here, Robert. It's all fine to think you're going to be a space explorer when you're 12, but now you're an adult, you got to have a trade. So I knew a lot of science. I became a science teacher. And I did that for about 7 years. So there I am living in northern Manhattan and teaching in Brooklyn and taking the A train each way, an hour and 15 minutes each way, and reading novels by Herman Melville about sailing the South Seas and saying, what am I doing here? Okay. And by this time I had realized there was this thing called grad school and you could become an engineer. And so I applied and I got in to University of Washington in Seattle. Now, at that time, now we're talking the early 80s, I believe the most important thing that's going to happen in technology in the remaining part of the 20th century was fusion power. So I majored in nuclear engineering, and I'm doing that. And I also, though, started taking aerospace courses on the side because I was interested in that. And then I heard about this group called the Mars Underground, which was holding meetings in Boulder. And these people of my own generation, people like Chris McKay, Carol Stoker, Penelope Boston, very much just about my age, and very much the Apollo's children who had been betrayed by the failure to continue it. And they were saying, let's put Mars back on the agenda. So I went to the third Case for Mars conference, which was 87, and Carl Sagan spoke there. And by then they had attracted some pretty prestigious people, Thomas Paine, people like that. And wow, okay, so this is great. And also by this time, the fusion program, which I had a very good knowledge of because my PhD advisor was in an elite position within it, and he knew about what the funding decisions were going to be this year, next year. He knew all, and it wasn't looking good. Okay, and but meantime, while the scope of the fusion program was narrowing, here was this multifaceted problem involving everything from trajectories, propulsion, life support, science exploration. It was a very interesting design problem. And of course, it was like the war horse hearing the trumpet. I was drawn back. Okay. And so at the 87 conference, I made contact with Ben Clark, who you may or may not know, but he was leading the human Mars mission studies at Martin Marietta, which later became Lockheed Martin. And I went up to him, and I had this strong background in both nuclear and aerospace engineering, and he said, send me your resume. And I did. And a year later, I was working at Martin doing preliminary design of interplanetary missions. And it was a couple of years after that I came up with the Mars Direct plan, which made me prominent within the aerospace community. And there you have it.
I'm fascinated with that because I remember the Mars Underground, and the title was appropriate because you kind of had to be underground, didn't you? I mean, it wasn't appropriate at that time or on the radar of policymakers to really be thinking about that. Am I right?
Yes. And in fact, to tell you a little story, around 1982, when I was still a science teacher in New York, I heard the American Chemical Society was having its conference in Manhattan. And one of the speakers was Hans Mark, who was the deputy administrator of NASA. And there was a panel of like astronauts and then him. And he got up and he gave this speech. He said, look, we got the shuttle flying, and now we're going to do the shuttle, and we're going to have reconnaissance satellites and weather satellites, and they'll all be launched much cheaper because the shuttle is a reusable launch vehicle, and this is what's going to happen. And so I got up with this mic on the floor, and I said, what about humans to Mars? Why aren't we supposed to go to Mars? And he basically said, well, those were the dreams of youth. But now we've gotten realistic, and we understand that space is for important commercial purposes and so forth. And then he was interrupted by a female astronaut who was on the panel, who was Judith Resnick.
Oh, yeah.
Mm-hmm. Okay. And she said, no. Okay. You're right. But if you want to make it happen, you've got to make it happen. Okay. There you have it. So, of course, Judith Resnick was killed on the challenge. But there you go. But I actually didn't start working on making it happen until I joined the Mars Underground, which was a few years after that. But still, I can remember that. It was
Is it fair to say? Is it fair to say that had an impact? And
yeah, it did. And I was coming from exactly the same place that the other Mars Underground people were coming from, which is, weren't we supposed to go to Mars by now?
right.
Okay, and what happened to the visionary space program. And indeed, we were supposed to go to Mars by the 80s. And what Nixon had done in canceling it was like Columbus comes back from the New World and Ferdinand and Isabella say, so what? Who cares about this? That's more or less what had happened. And so what and here I'm grouping myself with the Mars Underground, although they actually started in on this before I did, wanted to do was correct this mistake.
Yeah. Well, now things have changed. There is a lot more interest in Mars, but there are quite a few issues that are raised. Some of them are political, some are sociological, some are technical, and it's much more in the public eye. And I think that's largely because of you and also because of upstarts like Elon Musk. But you've had an incredible amount of opportunities to think about it since the 80s. What do you think are the most important or significant issues surrounding a human community on Mars today?
All right. Well, okay. So now there's two drivers for Mars. There's the immediate driver, which is the scientific question. Mars is where the science is. It's where we're going to find out the truth about the potential prevalence and diversity of life in the universe. And that certainly was the primary motivation of people like Chris McKay, Carol Stoker, and so forth. And it was something I was very interested in too. But there was another aspect to it, which is that it's where humanity's career as a spacefaring species could begin. It's a much more favorable place for settlement than, say, the moon, for example, than vastly more so than Earth orbit, where some people thought we could build free-floating colonies by importing billions of tons of material. So it's a lot easier to settle a planet than to build one. Okay, and Mars is this now. Okay, look. If we're talking about the settlement question, and that's what you're asking about, not this other thing. Okay. Yeah. I believe this is important for the human future. I believe it is fundamental, okay, but for a different reason than some people have voiced. I do not agree or find much merit in the argument that has been voiced by a number of people saying we got to settle Mars so that if Earth is destroyed, there's survivors somewhere else. I find that argument completely unappealing. The reason why we need to settle Mars, there's two reasons. One is for the same reason people have children, it's to establish a new creative branch of human civilization that will make its contributions to the human future. So we want to create new creative branches of human civilization on Mars. Okay, well, that's a good thing, but why is it absolutely necessary? Okay, in this case, my answer is the following. What is the greatest threat facing humanity today? Now, if I asked you this question, say, 2 years ago, most people would say climate change, would have said climate change. Now, some people still might say that. I think more people at this point might say war, as a far more imminent threat. And I would agree with that. And there still might be a few people who say things like overpopulation or resource depletion or something. Now, climate change is real, but it's not going to kill you in the next 5 years, even if nothing's done about it. I don't believe that resources are being depleted. I don't believe there's any such thing as overpopulation. War is a real threat, and that could kill you in a couple of years. But what is the driver? Why are we in a pre-war situation? Okay, fundamentally, it's because of bad ideas, and in particular, one bad idea in a variety of forms, the same bad idea that caused the great human disasters of the 20th century, which is there isn't enough for everyone. And that makes us all fundamentally enemies. Okay, now we can group together in various alliances and so forth, but those are tactical in their convenience. That fundamentally we're all enemies because there's only so much to go around, this belief says, and therefore we have to take it from them, or we have to knock them out before they take it from us. And this is what drove the disasters of the 20th century. Okay. And it's what is what's fundamentally threatening now. And you know, you've got the situation with Putin. Actually, I think this one can be dealt with if the NATO rises to the occasion and it can supply Ukraine with enough arms to repel this invasion, and that'll end this for now. But there's China there. Okay. And I mean, I happen to know for a fact that, because I've spoken to them, that there are people in the American national security establishment in positions of significant responsibility who believe that war with China is inevitable. Okay, why? Because there's 1.4 billion of them, and if they all start driving cars like Americans or even Europeans, there won't be enough oil in the world, don't you see? And you could bet your bottom dollar that there are people exactly like them in Beijing, okay, who look at this from the other side of the chessboard and think pretty much the same kind of thoughts, except with a different target for elimination. Now, and if that kind of thinking is allowed to prevail, it's going to be war, okay? And it'll be much worse than the world wars of the 20th century because our weaponry is far more effective now. But it's a fiction, you see. It is a fiction that the human race is divided into competing races that are in a struggle for existence over limited resources. Okay. It's a fiction because, I mean, why is China able to develop today? Okay. Well, it's because largely, I mean, why has there been spectacular development since 1990s? Inventions made in the West, including electricity and advanced technologies, iPhones, automobiles, trucks, okay, et cetera, et cetera. And so they would be much worse off if the West had not been prosperous enough to invent all this stuff. On the other hand, the West owes its renaissance to things like paper and printing that were invented in China. So it's not really true that the different nations are in a struggle for existence over limited resources. What's actually true is that we are a family of nations, a rather disorderly family to be sure, but nevertheless, a family that is engaged in a joint project to expand the total amount of resources available to humanity through creative invention, because it's inventions that define what are resources. Okay. Now, that's the truth. That's why, you know, when you and I were small, the world had a population of 2 billion people. Now it's 8. And yet, on average, a much higher standard of living, not less, as the population crisis people were claiming in the 60s. We'd all be starving by the year 2000 because the population was going to get too big and so forth. Okay, exactly the opposite. Yet, it seems intuitively true that it must be the case that there's only so much to go around. Okay, here's the Earth. Okay, maybe there's some oil we haven't discovered yet, but fundamentally, there's only so much here, and sooner or later, we're going to have to fight them for it. Okay, it's false. But trying to explain that to someone or prove it to someone is like trying to convince a person who doesn't know mathematics that there's an infinite number of points in a 1-inch long line segment. That is, to the mathematically naive person, it seems obvious that the number of points in a 1-inch long line segment has got to be finite, right? It's common sense. But anyone, even a naive person, could see there's an infinite number of points in a line that extends infinitely in both directions. All right. So it's not that the resources of the Earth are infinite. It's that, or finite, excuse me, they are infinite. It's that they appear to be finite, and we can end up killing each other over this belief that there's only so much to go around. And so it's not that we're going to get oil from Mars. We're not going to get oil from Mars. We probably will get useful inventions from Mars. I'm pretty sure about that. Okay. But the main thing we're going to get from Mars is the truth that there's no point killing each other over provinces when by working together we can open planets.
So I suppose another way of looking at it would be, why don't we simply change this false belief rather than going to Mars? Why don't we simply remain on the Earth and put all our energy into changing the false belief?
Well, we should try to change it by every means possible because it is such an existential threat. But, look, the potential of science and technology to expand resources was obvious even by the mid-1800s. Okay. Oddly enough, Friedrich Engels, the associate of Karl Marx, wrote a brilliant refutation of Malthus in the 1840s. And everything, he had it all 100% true. No, this is all absolute nonsense. Science is going to expand resources. And Engels, being who he was argued that this was in fact really just an alibi for oppression, that there's only so much to go around, so sorry, poverty is inevitable, which to a certain extent is true. Now, and Hitler, okay, who wanted war, wanted people to believe in the necessity for war, okay, he actually said, this idea that we can have perpetual progress and plenty through scientific progress he said it was a Jewish plot to dissuade people from believing in the necessity for war. Now, it's not a Jewish plot, but it does dissuade people from believing in the necessity for war. Okay. But nevertheless, you see, once again, it seems we can't afford to lose this argument. Okay, yes, all forms of terrestrial science and invention should be encouraged to make it clear that resources are infinite. Okay, this is why it's extremely important that things like nuclear power and, yes, fusion power be developed to their full potential. Okay, so that, you say, okay, well, the problem is global warming. Yeah, global warming and carbon emissions are a problem, but we can get past them with higher technology that actually create more abundant energy, just as fossil fuels themselves created more abundant energy with less environmental impact than cutting down forests. Mm-hmm. Okay. So yeah. So we need to do that. This stuff, but both the inventions we can implement on Earth and the opening of space are two ways to make this case.
Are you really more interested in the opening up of, let us say, the solar ecosystem as a whole, but Mars is the best destination? Or do you feel like Mars is the singular most important destination? Is it the one that really deserves the most attention because it's the most Earth-like and it has water and so on?
It's the one that deserves the most attention now. It's not the limit. It's not the ultimate goal. As Michael Collins once said, it's not the destination, it's the direction. Mm-hmm. And it is the new world for our time. Okay. And it is the key to creating a spacefaring civilization, which ultimately will not only develop the solar system, but open the path to the stars.
So even though, well, that goes to terraforming, for example. How do you feel about that, in the sense that it would be a fundamental alteration of the ecosystem. Is it your view that that is acceptable ethically, and you would
Oh,
have
I think it's not only acceptable, I think it's extremely desirable. I think that the idea, okay, look, if you can destroy an environment, you can improve an environment. Okay.
Mhm.
It's not that all change is wrong. Some changes are good, some changes are bad. Okay. Now, if anybody came along and said, let's make Earth like Mars, let's get rid of all these forests and cities and people and, and even the fish and so forth, and let's just have some bacteria here, people would say, hey, you're out of your mind, okay? And it wouldn't just be the Sierra Club that would have that position. That position would be taken by anyone except for some kind of death cultist, okay? Now, we'd all would agree that would be a horrible thing to do, okay? Now, so therefore, if one could do the reverse and take a dead planet and bring it to life with a glorious biosphere as well as creative human civilizations, that clearly be a wonderful thing. And to abort that from happening would be criminal. Okay, so there it is. It's this idea that anything humans do that changes the environment is intrinsically wrong. I don't buy it. Okay, that's just being anti-human. Anything you do is wrong. Okay, there are some things we do that are right and some things we do that are wrong. And this would be something we could do that would be right. And I think if we did it, everyone would be proud to be human and contemplate. No one could look upon it and not be proud to be human.
What do you think is the largest number of people that could be supported on Mars? I mean, assuming that you were in charge and everything you thought should be done was done, can you imagine what the carrying capacity might be?
Well, okay, there's no such thing as carrying capacity of a planet. It is people that carry people. Okay, in other words, these people, can say, oh, the Earth only has a carrying capacity of 1 billion people. That's not true. There's 8 billion people on Earth, and we're living vastly better than we were in the 1950s, let alone the 1850s or the 1050s. And okay, but let's take a step back. Okay, I believe that Mars will be settled by a multitude of city-states with diverse ideas on what the best society should be. Okay, the Mars Society held a contest a couple of years ago on design of Mars colonies, and between the two contests that we held, there was almost 300 entries, and they designed social systems, everything. I mean, most of them were on a spectrum from social democratic to libertarian, but there were also other ideas that didn't even fit into that spectrum. Okay, and you could argue about this stuff. Should there be universal basic income, or does that suppress initiative? And okay, well, there's going to be people with all sorts of ideas, and you know what's going to decide which one prevails? It's which one works the best, which one attracts the most immigrants, and it creates the greatest economic prosperity, and has the most children. Okay, all these things will be involved, and you could have some that work well enough to survive, but they will be outgrown by others that work so much better at every level, from the technological to the political and economic to the aesthetic, that they attract far more immigrants and outgrow them, and they become the model of what Mars becomes. Okay, and so now the terraforming, I think, will eventually happen because it's the nature of life to transform barren environments into those that are favorable for the development of life. That's how life transformed the Earth radically from its initial condition to now. And so we're going to do that. But obviously that won't be done until there is a rather substantial human presence on Mars that has large-scale industrial and technological capabilities that can actually address a project on that scale. But I see no reason why there couldn't be thousands of cities of 100,000, eventually a million or more on Mars, just as there are now on Earth. You know, I mean, look, 500 years ago, there were only, well, maybe one city on Earth, maybe Beijing or something, that had 1 million people. And at an earlier date, there was also ancient Rome. Now there are dozens, I don't know how many cities, there are probably at least 100 cities in the Earth with over 1 million people. I haven't counted, but there's quite a few. And maybe several hundred. So our potential is increasing. You go to Mars, there's no such thing as a natural resource. There's only natural raw materials. It is human technology that turns a raw material into a resource. Land was not a resource until people invented agriculture. And its magnitude as a resource has been multiplied many times over as agricultural technology has advanced. Oil was not a resource until 1859, when Colonel Drake drilled the first oil well, and then it became a much bigger resource as we discovered a lot more oil and figured out more products that it could do beyond lighting lanterns, and invented all sorts of machines that could run on stuff like gasoline and everything. Okay, uranium was not a resource till we developed nuclear power as a way to make red dishes. Now it's a giant resource. Do you know? Okay, you live in New England, right?
I do.
Okay, so you got these granite mountains in New Hampshire. Okay, do you know that a kilogram of New Hampshire granite contains enough uranium and thorium to generate 100 times as much energy as an equal mass of gasoline?
I did not know that.
Okay, I mean, think about that for a minute. Okay, now we don't in fact get our uranium from granite. We get it from more concentrated sources. But if you wanted to, if you really had to, you could. So, it's like Moses got water out of the rock. We could get energy out of rocks, okay? And it's not the rock, it's the creative thought that's brought to the rock that turns it into a source of energy, okay? Mm-hmm. Okay, so if you next time you drive through New Hampshire and you see all these great granite mountains around you, there's mountains of energy all around you, mountains of it. Okay, vastly more than the oil of Saudi Arabia, and it's all a question of developing the technology. Now, now, if you have energy, you can make all sorts of chemical transformations that can create anything you want. Okay, and so we go to Mars, and there's also deuterium on Mars. Actually, deuterium is 5 times as common on Mars as it is on Earth, and that's the basic fuel for fusion reactors. So between the Martian thorium and Martian deuterium, and so you got energy, and if you've got creative people there, okay, if you got resourceful people there, you'll have resources there. Okay, because it's the resourceful people that create the resources. It's a very common observation. So I think, yeah, Mars can someday be a planet with the population density comparable to the Earth.
In the near term, I mean, you're painting a picture of a Mars that's really Earth-like, and therefore it has a population, it has cities, it has people. In the short term, what is the business case for Mars? It seems like your vision is not that near in time, though.
Okay, so what's the more near-term vision? Okay, and by the way, I should mention to you, I'm currently working on a book. It's already been sold to a publisher, called New Worlds on Mars. and it discusses all these possibilities. And once again, it doesn't lay out, here's my plan. It rather explores what's likely to work. What are the options? What's likely to work? What's likely to emerge on Mars? Obviously, just from the point of view of the natural selection, which is a tautological theory, you want to know, that is what survives is what survives. What succeeds is what succeeds. But okay, two things. Number one, I think a Mars colony will be a colony of a group of technologically adept people in a frontier environment where they're going to be forced to innovate and free to innovate. And so they're going to innovate. You may be acquainted with the frontier thesis of Frederick Jackson Turner, who wrote The Significance of Frontier in American History. I believe this will hold true on Mars, but it will hold true to the nth degree more so. That is, you're going to have a labor shortage on Mars, just as you had one in colonial and frontier America, which is going to drive technological innovation, first and foremost for labor-saving machinery. Of course, Americans became famous as gadgeteers, labor-saving machines of every type. Well, you'll have both that and more advanced equivalents, automation, robotics, artificial intelligence, all these things that amplify or diversify the power of labor. The Martians are going to be virtuosos at this. And these inventions will be licensable on Earth. The new sources of energy, perhaps fusion power. You know, the British invented the steam engine. Americans invented the steamboat. And this was in the 1790s. We barely had gotten started. We made a world historic invention. Why? We needed it because the highways of early America were the rivers, and sailing ships are really not too great on rivers because the river is going one way, and you needed steamboats to do it, and we did it. And in consequence, we invented the high-pressure steam engine, which then became the basis for railroads and could totally transform the world in the 19th century. Things like this. So the Martians, I think, are going to be driven to develop fusion power. On Earth, I mean, there's a lot of ways to make energy here. You got fossil fuels, and you can burn them with oxygen, which is free, and you can have lots of energy. Solar energy, is not that great on Earth, but it's 2.5 times as good as it is on Mars. Wind is possible, not really on Mars. Waterfalls, not on Mars until it's terraformed, but nuclear power and especially fusion power. So they'll do that. The robotics I mentioned, greenhouse agriculture. On Earth, you got all this free land. You can afford inefficient agriculture.
Mm-hmm.
On Mars, you're working with greenhouse agriculture. You want to have the highest possible yield for square meter, and it's going to be very intensive. And you're going to want to really get into the potential of bioengineering to create by far the most productive plants and ones that can be designed to be the most nutritious or have pharmaceutical values and so forth. Okay. So all these sorts of inventions. So this will be one major source of income. Mm-hmm. The other source of income is going to be what you might call selling blue jeans to asteroid miners. That is, if you want to get rich during a gold rush, you don't go for the gold, you go for the miners.
Right.
Right. And the people who made the big money in the California gold rush were not the gold miners, but people like, Levi Strauss and so forth, who set up the concessions to sell to the miners. Mm-hmm. Right. Now, as you know, there's massive precious metal resources in the asteroid belt. Okay. I do not believe that asteroid mining operation is going to have the diversity of skills required to produce all the consumables needed to support that operation. Asteroid belt is much more accessible from Mars, about 2 orders of magnitude cost advantage in reaching the asteroid belt from Mars than from Earth. So if you think of, for instance, the colonial period, where The actual colonies that were producing commodities for sale in Europe were really the Caribbean sugar plantations. But those were not complete economies. Okay? They couldn't make all the craft goods, they couldn't wagons, and they couldn't grow the food crops and so forth, and iron and things necessary to support themselves. So where'd they get it from? The American colonies. Traded with them. They sold the sugar in Europe. Okay, so they got money, they gave us money, and we would buy the most advanced goods from England. Triangle trade, right? I think that will happen with Mars. That Mars is the point we can access the entire outer solar system, and it will be the place in which a lot of things that you can't make in the asteroid belt, you can make there. Probably the most technology intensive goods make on Earth.
Yeah.
Okay, you have a much bigger division of labor, so you can make the most sophisticated stuff. But, you know, the Martians are not going to want to import food to Mars. You're not going to want to import steel or aluminum to Mars or glass. So if you want food on Mars, okay, you grow the food and you make the glass for the greenhouse, and you even make the motors for the fans in the greenhouse. But the chips that control the motors in the greenhouse, well, you probably get them from Earth, but they don't weigh very much. So you can make millions of tons of food with kilograms worth of high tech from Earth, if you make all these intermediate materials first. So, but a lot of that kind of stuff, you won't have a complete economy on an asteroid mining outpost. Okay, so the blue jeans will come from Mars.